So I'd like to do the first breakout session. So I think this is Rick Bartow, who's going to talk about the initial session and bring it open to the group. I'd also take a moment, since we weren't here earlier, to introduce our co-executive director for the Hub, Leah Shanley. She's in the corner here. Raise her hand. Here we go. So we're partners in crime. So Rick, come up.
Thanks, Renata. So our group was covering the materials manufacturing and innovate. Am I on? Can you guys hear me?
Yeah.
Is it on? Okay. We were covering the materials manufacturing innovation cyber ecosystem. It was moderated by Dave Fries from FHMC. So we covered three things. What is the definition of a cyber ecosystem? Then we talked about gaps in the system, in the ecosystem, and aspirational goals for future research. So I came up with a definition. I'm going to need some help from Craig. Where are you, Craig? In fact, it might be better for you just to say what you said. All right, I'll take a wing at it. Definition of the cyber ecosystem is computer, IT resources, networking, security and policy requirements, data management, and software, including human-machine interfaces and visualization for materials and manufacturing, including emerging services and business models. There's got to be a more concise way to say that. Talked about the merging of the physical with the cyber in the materials world. Now that we have embedded computing and sensors in our hardware, we talked about security protection as being a huge issue. In this merging, there's the merging of materials with digital and image representations. Right. And then there's this concept that in additive manufacturing, we could now think of the parts that we're making as digitally renderable with their defects and geometric tolerances. So now that component or that material is effectively a digital image. Products of the ecosystem should be manufacturing improvements, materials information available to design, and a clear understanding of structure property relationships. We should be able to provide collaborative platforms between organizations. That would be, or I should say, collaborative platforms for organizations to organizations, humans to humans, humans to machines, and machines to machines. Kind of the existing state, gap analysis. Currently, a lot of our lab equipment and additive machines and materials characterization tools are quite isolated and standalone. A lot of this is because we have a lot of legacy systems that are, frankly, still working on DOS and can't talk to any network. You have platform-specific data formats, so we're missing protocols. We have poor interoperability between platforms. And as Craig mentioned, security is a huge issue for our industry and the DoD. Stifles innovation. Sometimes it can take months to a year to install a new computer or system. David use the example of, one of the problems he's working on today is registry of air drones, the registration of something like 800,000 UAVs, which is currently obviously a security issue, but somehow that community is making it work in something called a permissionless environment. Is there some way we could get to that kind of security protocol for materials, data, and manufacturing? We said there's currently no effective system that allows innovation that's compliant with our current security and regulations, and we don't make effective use of metadata. Let's see. So we talked about something called software-defined exchange systems for data. This would be the idea of kind of borrowed from other communities, using third-party software-defined data exchange infrastructures where the owners can provide their own exchange policies and enforce them. So another issue that's related to some of the talks we heard this morning, that we have pretty significant infrastructure for handling large data. For instance, the DoD can routinely handle terabytes of data, but the tools for interfacing with them are very command line driven. There's a huge barrier to entry for novice users. So we need improved interfaces.